In this video, we are going to look at how to draw electron dot structures for any molecule. First of all, an electron dot structure is basically a way to represent how the atoms in a molecule are bonded together and how the valence electrons are distributed around that molecule. Electron dot structures, you may also hear them called Lewis dot structures or Lewis structures. In this representation, electrons are represented as dots, and covalent bonds are represented as straight lines between two atoms. A covalent bond, of course, is a shared pair of electrons between two atoms. And electron dot structures, it's important to note that electron dot structures are generally only used to represent the structures of molecules. Molecules are two or more non-metal atoms which are covalently bonded together. So ionic compounds or metallic compounds, they are generally not represented using electron dot structures. So there are 5 steps that you need to know in order to correctly draw an electron dot structure. And it's important that you become very familiar with these steps and follow them very carefully. As I go through the steps, I'm going to use the nitrate ion as an example of how to draw, how to follow each step and how to draw the dot structures. So the first step in your electron dot structure is to count up the total number of valence electrons. So each atom has a certain number of valence electrons, and you can determine each atom's valence electrons by looking at its group number. If it's in group 5, then it has 5 valence electrons, etc. Now, if you have an ion, a molecular ion, you want to add 1 electron for each negative charge it has and subtract 1 electron from the total for each positive charge it has. Okay, so let's take a look at the dot structure for our nitrate ion. First thing we need to do is determine how many valence electrons this molecular ion will have. Nitrogen is in group 5, so it has 5 valence electrons. Oxygen is in group 6, so it has 6 valence electrons, and we have 3 oxygens in our molecule. Now we have a negative charge on this molecule, so our rule tells us that we need to add 1 electron to the total. So here we have 18, 5, and 1. We have 24 total valence electrons. The second step is you want to connect the atoms. So the first thing you have to do is determine what your central or center atom is going to be. Generally, the central atom is the least electronegative. One exception, though, is hydrogen. Hydrogen can never be your central atom. It can only form 1 bond, so it can never be a central atom. Once you determine your central atom, connect each of your other atoms to the central atom with a straight line. The atoms connected to your central atom are generally called terminal atoms. Each straight line represents a covalent bond, and of course each straight line or each covalent bond is a shared pair, so 2 electrons. We need to determine our central atom. Our nitrogen is the least electronegative, so that's going to be our central atom, and we draw a single bond between the nitrogen and each oxygen. Okay. Step 3, you need to assign the electrons to the terminal atoms. Now you've already added some bonds, so each bond, as we mentioned, represents a pair of electrons. So subtract the number of electrons used in the bonding from the total. The remaining electrons you want to add 2 at a time around each terminal atom until each terminal atom has an octet or 8 electrons. So you add the electrons in pairs around a terminal atom. Once it has 8 electrons, then you move to the next one and add the electrons around that terminal atom until it has 8. Now remember, when you're counting the electrons around an atom, count the bond as well. That counts as 2 electrons. Now hydrogen, if that's one of your terminal atoms, that's an exception. Hydrogen cannot have an octet because hydrogen only has a 1s orbital, and so it can only have a one single bond. It can't have any lone pairs. Now, each bond is 2 electrons. It's a covalent bond, so this is 2, 4, 6 electrons. So we subtract 6 electrons from our total. 24 minus 6, we have 18 electrons remaining. Now we put the electrons in pairs around our terminal atom. So that's a pair here, until each terminal atom has an octet. So this oxygen, we've put 2, 4, 6, and then the single bond here counts as 2 electrons. So this oxygen has an octet. Now we do the same thing for our other oxygen. Doesn't matter which order you do them in. Now this oxygen has 2, 4, 6, 8 electrons around it. It has an octet. And now the last terminal atom, let's put the electrons 2 at a time around it until it has an octet. So now we have placed 2, 4, 6, 8, 10, 12, 14, 16, 18. So we've placed an additional 18 electrons. So we have 0 remaining. Step 4, assign electrons to the central atom. If you have, after you've completed step 3, if you still have electrons remaining, then you put them 2 at a time around the central atom. So if you don't have any electrons remaining, then you don't need to do this step. But if you still have some electrons left over after step 3 that haven't been placed, then you put them around your central atom. So we have 0 remaining. So we don't need to put any electrons around our central atom because we don't have any more remaining. And the 5th and last step is the multiple bond step. After you have placed all the electrons around your terminal atoms and your central atom, if necessary, then you need to check to see if your central atom has at least an octet, or at least 8 electrons. So count the electrons, the bonding pairs and the lone pairs, if any, around your central atom. If your central atom has less than an octet, then you need to make multiple bonds in order to give it an octet. The exception to that is boron and aluminum. Boron and aluminum, if they are your central atom, then it's okay for those guys to have 6 electrons and not an octet. Also of note, if your central atom is in period 3 or greater, then it's allowed that that central atom can have more than an octet. So it could have 8 electrons around it. It could have 10 or 12. That's okay. But it must have at least an octet. If the central atom does not have an octet, then you take one or more lone pairs from one of the terminal atoms that it's attached to and transfer that from a bonding pair to from a lone pair to a bonding pair. So you transfer a lone pair and make it either a double or triple bond, and you do that until your central atom has at least an octet. Now, it's important to note that you only check for multiple bonds after you have placed all the electrons. Don't do that until the very last step. Now, in our final step, we need to check to see, does our central atom have at least an octet? Our central atom has 2, 4, 6. Each of these bonds counts as a pair, so it has 6 electrons. It is short of an octet. So our rule tells us that if we are short an octet, we take one of our lone pairs from our central atom, it doesn't matter which one you choose, and you turn that into a bonding pair. So it doesn't matter which lone pair we choose or which oxygen we take it from, but we turn a lone pair into a bonding pair. Now our central atom has 2, 4, 6, 8, so it has an octet, and this oxygen has 2, 4, 6, 8, so everything still has an octet. Now, one last thing, if you have an anion or cation that you are drawing the structure for, it's generally a good idea to put brackets around the final structure and then put the charge on the outside. So here are some molecules that you can practice drawing the dot structures for. So try to draw the electron dot structure for each of these molecules, and once you've attempted it, then check your dot structures against the key that I have.